We would like to begin the conference day 2. Today's first speaker is Mr. Hideyuki Tokuda, President, National Institute of Information and Communications Technology, Vice President of Beyond 5G Promotion Consortium. Mr. Tokuda, please.
Thank you for your kind introduction. I'm Hide Tokuda, the President of the National Institute of Information and Communication Technologies. Today I would like to talk about accelerating beyond 5G, 6G R&D in NICT. I will maybe spend 20 minutes, talk about At first, I will introduce you a quick overview of NICT in a short video, and then I will focus on the various activities we did in year 2023. Okay, let me see.
NICT will continue our endeavor with Beyond 5G, AI, quantum ICT, and cybersecurity to create a bright, exciting future through inspirational next-generation research and technology.
Okay, we are the Japan's only public research institute specializing in information and communication technologies. We are located in Koganei, Tokyo. Our personnel is about 1,380 or 1,400 some, and about a bit over 700 is researcher doing various type of ICT-related research. Every 5 years, we have a so-called, we set a mid to long-term plan. And right now, we were third year, ending the third year of the fifth mid to long-term plan. We started April 2021. NICT has 3 roles. First one is, of course, the research and development of ICT. In addition to R&D activities, we have a very important task, which is public services. We maintain Japan Standard Time. We provide the space weather forecast. Lately, we actually trained a bit over 3,000 civil servants every year for cybersecurity training. In addition to these public services, we act as a funding agency. We try to support beyond 5G R&D activities. And also we have international collaborative funding, namely like US-Japan, EU-Japan, ASEAN-IVO, ASEAN-Japan project, and Taiwan-Japan project, and so on. Here's a quick map of our facilities in Japan. At the north area, you can see in Sendai city area, inside the Tohoku University campus, we have a resilient ICT research center. And then around the Tokyo area, we have Yokosuka Research Park area. We have a wireless network research center and headquarters. And then in Kansai area, we have many research institutes like Universal Communication Research Institute, Advanced ICT Research Institute. At the south, around in Okinawa, we have Okinawa Electromagnetic Technical Center. Around the overseas, actually, we have one branch in Washington, D.C. in US, and a sub-branch in Sunnyvale in California. And then we have a European center in Paris, France, and then Asian center in Bangkok, Thailand. As I said, every 5 years we have to set mid to long-term plan. And around the year 2020, we were setting up a fifth mid to long-term plan. So we talk about the shape of future society around the year 2030. As many previous researchers mentioned about the achieving SDG goals or trying to provide carbon neutral society. In addition, our Statistical Bureau of Japan estimated that our future society around year 2030, more than 30% of the population will be super elderly, means like over 65 years old. By year 2050, we will have like a 38% of the total population. So maintaining the labor force in our society is very important, and elderly care is also important. So these are the social needs, and then we discuss about the central core philosophy. It should be a human-centered, sustainable, inclusive society. And then we may need new social infrastructure to create the new values by transforming the industrial structure and working environment in our future society. So in addition to the basic 5 research institute, we set the 4 strategic fields, namely beyond 5G, 6G, AI, quantum ICT, and cybersecurity. These are the 4 strategic research fields we were focusing on. So I will mention more detail regarding beyond the 5G, but let me quickly cover the quantum ICT and cybersecurity and AI. Both are tightly coupled to create beyond 5G, 6G technologies, or I should say infrastructure. Quantum ICT, NICT is a quantum security hub in Koganei. So we need to provide quantum safe, secure communication technologies. We also are trying to encourage the young student and young graduate student to be a quantum native. Many industries in Japan may need a new type of not only just a digital native, but a quantum native human resources. In terms of cybersecurity, we set a new section called the Cybersecurity Nexus. We're trying to provide a very important data related to the cyber attacks or cybersecurity intelligence information among the governmental institutions, universities, and industries. We're trying to be a hub. And at the end, at the last but not least, we're trying to create new AI computing facilities in Kansai area. As you may know, many research institutes working on generative AI technologies. However, one of the challenges is how can we maintain the large number of GPUs? So we had several hundred V100, A100, and then we're trying to accommodate more future computing resources in these facilities. By the way, we created the NICT version of large language model with 170 billion parameters. Lately, we succeeded with a bit over 300 billion parameters, focusing on the Japanese data set. Okay. So let me summarize in terms of beyond 5G, 6G. So the beyond 5G, 6G, AI, quantum ICT, and cybersecurity, so namely the strategic 4 fields. This technology will drive innovation in all aspects of daily life, industry, medical care, education, disaster prevention, and environment. These are extremely important foundations for human-centered, sustainable, and inclusive societies. So by saying that, let me quickly focus on our activities in year 2023. So as I mentioned, that our main role is a research and development organization. So we have good research results on telehealth, NTN, non-terrestrial network, optical communication, namely multi-core, multi-mode fiber, We have a world record on this. And then space-time synchronization and so on. At the same time, we are focusing on providing open beyond 5G, 6G testbed facilities. Traditionally, NICT providing the network layer services for ICT developers. It's called the Japan Gigabit Network, JGN facilities. But in addition to the network layer, we're trying to add the middle layer and then platform layer. We have something called the DCCS, Data-Centric Cloud Services. So we are hoping that many of you here attending this conference will be participating in this testbed exercise as well. The third activity is funding agency activities. We supported Core 1, Core 2, Core 3. We started the Core 1 in year 2021. And Core 2, Core 3 started in 2022. And then now we have a new research fund, which is more focusing on the industrial development, or namely, I should say, in Japanese, it's called social implementation. Okay, and then we have Beyond the 5G promotion consortium activities. Dr. Toyoshima and Dr. Hosako from NICT will talk about our contribution to the consortium. And then we do lots of information dissemination, demonstration, standard activities, international collaborations, and white papers and producing documents. So let me quickly jump into a bit more detail. So we have a very wide variety of activities in NICT, but we just pick up 6 topics here. Because of the time, I cannot jump into detail, but we have a telehealth, wireless communication activities. We have some demonstration picture in the later slides. Multi-core, multi-mode fibers. So our team actually come up with 38 core with multi-mode transmission. It achieved a world record, namely 22.9 petabit per second. But maybe distance is not so big, but it's a new world record. And then NTN technologies. We have a long history of NTN technologies, and NICT started back in 2002 to practice the notion of NTN technologies. In cooperation with JAXA, Jamstick, NICT succeeded with IMT 2000 with digital TV signal transmission using NTN technologies. And then we have a very strong team because we maintain the Japan Standard Time. Chip scale, by using MEMS technologies, we are creating an atomic clock. That will give us the new capability, functional capability, namely like a precise positioning system proposed in IMT 2030. Okay, we are hoping that we can revolutionize the precise positioning system. Even we lose the, say, GPS signals, we can maintain the precise positioning system on the ground. And then we have a virtualization. Many people already discussed about AI and cloud native technologies, and also network slicing technologies. Here's some snapshot of the NTN technologies. We were working on the compact optical communication terminals that can utilize for many mobile platforms, realizing ultra high speed, large capacity, scalable beyond 5G networks. For instance, like a Leo 2 Geo, we are targeting 1 gigabit per second. Leo 2 Leo, 5 gigabps. For instance, like a HAPS to HAPS, I don't know it's true or not, but air to air transmission, trying to achieve 2 terabit per second. Here's our test bed, picture of the test bed. As I said, not only the network layer, we provide the middle layer, namely SciReal, proof test environment. And then also we have a data-centric cloud services. So we have very specific B5G mobile environment, testing environment in Osaka University campus and also Kyushu Institute of Technology campus. One unique feature is that we have a long history of maintaining the quantum key distribution network, so-called Tokyo QKD. We're trying to combine the QKD service layer with the beyond 5G, 6G layers. So B5G, 6G network services will be multi-layered, many services, and then hopefully we can test these new features using that. Next slides talk about the international collaboration. As people from Germany already mentioned about the German-Japan workshop, we hosted the first German-Japan Beyond the 5G, 6G workshop in NICT last April. And then June, they had a second workshop in Germany. And then third one would be the next week, Monday and then Tuesday, in Nihonbashi Innovation Center in NICT. Here's another workshop we are working together with the French Research Institute called India. India NICT workshop was held in December. We extended the MOU towards the not only beyond the 5G and 6G, but also like cybersecurity, AI, and so on. The last one is talking about the information dissemination and demonstration ones. Sorry, the picture is too small, but we demonstrated some of the high-speed transmission using 300 gigabit terahertz communication. Here you can see at the center of the top, you can see the video transmission over the two devices. And then right-hand side, we tested ultra spot communication using robot applications. So by using IEEE 802.15.3e compliant devices made by Sony. So we have a very quick transmission, like they can establish the communication link in 2 milliseconds. They can transmit over 120 megabytes within 500 milliseconds. So this demo was among the mobile robots, but actually between two drones, we demonstrated very quick communication between two entities. Left bottom is a demonstration we did at the G7 Digital Ministerial meeting in Takasaki. We're trying to provide the service layer, what kind of use cases can be demonstrated using B5G, 6G. The right bottom corner is a very unique attempt. Actually, some of our researchers is interested in attracting the non-communication related expert into the B5G, 6G communities by providing so-called the patent ideathon or interesting app ideathons. So we have lots of ideathons trying to attract non-ICT people in this community. Here's a snapshot of our R&D promotion program funded by the MEC. Core 1, Core 2, Core 3 already awarded. In total, actually 73 projects are going. Almost some of them are finished. And then MEC changed the phase to the more industrial, emphasize the funding scheme. But we maintain some of the small amount for the basic research, including universities. By the way, NICT is a very unique funding agency. The Japanese funding agency tend to be vertically partitioned. Some funding agency can only support universities, only can support industries. But NICT, which is under MEC, can actually have a two-leg, not only academia, but also industries, or even including local government to combine together, creating a very unique interesting proposal to us, and then we can evaluate that. So it is a very unique position. Then we think that that kind of funding scheme is very important for promoting 5G, 6G R&D activities. The last segment is the standard activities. As many previous speakers mentioned about IMT 2030, we contributed many aspects of the new capabilities like time-space synchronization, telehealth, and NTN. So these are our contribution document. And hopefully, we can actually accelerate these standardization activities with ITU and 3GPP. Here's a new capability of IMT 2030. You saw many times already, but here we, NICT, contributed right upper blue zone called positioning. So the new positioning scheme can support 1 to 10 centimeter accuracy. At the same time, the coverage, left-hand side, blue corner, says coverage extension. So NTN is very essential for Japanese community or many other countries. We have lots of islands, and then trying to cover space-wise, okay, we have to cover the entire land. At the same time, also we have like earthquake in January 1st this year. We have Noto Peninsula earthquake, and then we need to have this kind of mobile, high-altitude ground station very quickly, so that these NTN technologies are essential for a country like us. At the end, let me conclude with this slide. We really appreciate if you are interested in participating our B5G, 6G trials or demonstration in 2025 at the Kansai Expo. We are willing to connect your new functionality with our B5G, 6G testbed. We are happy to collaborate with joint demonstration in Osaka. Okay, if you are interested in more details, please look at the NICT B5G R&D promotion unit page. Thank you very much.
Mr. Tokuda, thank you very much.